Aloha, everyone, and welcome to our stream of tonight's total lunar eclipse. My name is Roy Gal. I'm an astronomer at the Institute for Astronomy. I have two other folks, Alex Zierba and Nick Williford, who are amateur astronomers who have their telescopes set up as well, and will be providing some of the stream so that in case of clouds, we have multiple options. Aloha, everyone, and welcome to So I know all of you want to see an actual view of the moon, and everyone is welcome to go outside and look with your own eyes and look with binoculars. In a few seconds here, our stream should have a view of the moon from a small telescope. There it is. And you can already see the umbra or Earth's shadow starting to take a bite out of the moon in the lower left. And we are going to be on our way towards totality, which is about an hour away. So if you have questions about what we're seeing, I'll try to answer them. And later on, we may have someone joining us who can tell us about the lunar phases and their importance in Hawaiian culture. If you see the image shaking, that's because it's a little bit windy. You could do this from anywhere with any telescope. I happen to have a digital telescope that we're using, which makes it easy to transmit the image. But any small telescope will do for the job. And in fact, naked eye, you can just go out. You don't need, of course, any eclipse glasses or anything like that. And the nice thing is, the weather has cleared up. Actually here near the University of Hawaii at Manoa, that's where the headquarters of the Institute for Astronomy is, but a little secret, I'm just in my driveway doing this. So for those who are interested in exactly how a lunar eclipse works, I'm going to put up a graphic here in a few seconds that shows the geometry of a lunar eclipse. All right, so here you can see what's happening right now. And in this sort of top-down view of our solar system, where I want to emphasize that nothing is to scale. Actually, the Earth and the Moon are about the right size compared to each other in this picture, but the sun should be 100 times as big across as the Earth and about 100 sun diameters away. But just to fit it on the screen, the image has been made like this. And so you can see that what's happening during a total lunar eclipse is that the moon is passing through Earth's shadow. And as it enters the shadow, we'll see a partial eclipse. And then over time, it'll get more and more full. And because Earth's shadow is larger than the moon, it takes some time for the moon to go through Earth's shadow. So we're going to have almost an hour and a half of totality during this eclipse. The longest totalities are quite a bit more than that. But you can also have shorter duration ones depending exactly which part of Earth's shadow the moon passes through. And we don't have an eclipse every month because it's hard to tell in this drawing, but the moon's orbit around the Earth is not exactly lined up with the Earth's orbit around the sun. It's actually tilted, kind of like a tilted hula hoop. And so usually the moon is a little bit above or below Earth's shadow when it's on the far side of the sun from the Earth. So usually if we were on the dark side of the Earth at this time, we would see a full moon because it would be not be in Earth's shadow, it would be above or below it. But if it just so happens that the orbit of the moon passes through Earth's shadow, it's lined up exactly with the sun-Earth line, then we get an eclipse. And I'll put up another graphic, which will come up here in a few seconds, that tries to illustrate this. And because we understand the dynamics of the Earth and the moon and the sun and all the movement, we can predict when the eclipses will happen with very high precision and exactly where on Earth we're going to see them. And we can predict that out for hundreds of years. So this diagram shows in the middle the sun and then the Earth and the moon in different places of Earth's orbit. And you can see that the moon's orbit is tilted relative to Earth's orbit. So usually we don't get an eclipse. So for instance, if the moon is above the plane of the Earth's orbit, which is called the ecliptic, then you get a full moon at this time. But if it so happens to pass through the ecliptic, which we call a node, then you do get an eclipse. And so that's what we have this time. Let's go back and enjoy the view of the moon for a minute. So as you can see now, if you've been watching for a little while, we've got more and more of the moon falling into Earth's shadow. So this will be a nice slow process. We won't have totality for another hour or so. For those who are in places that are cloudy or that are facing away from the moon, and so you can't view the eclipse tonight, thank you for joining us. And it's a good thing that you are, because we're not going to have another total lunar eclipse until the spring of 2025. This is a pretty fun time to be watching a lunar eclipse since NASA is preparing to try again to launch the Artemis mission. So Artemis and the new SLS, the Space Launch System, is a system of large rockets and crew vehicles that are intended to send humans back to the moon and then eventually to Mars. So the first mission is a test of this new rocket system uncrewed, I should say, and then we'll be sending humans on future missions. And I think they've set November 14th for the next launch date, but I'm not sure. I can look it up. And we're being joined now by Leilani Lotzi, who is a community outreach specialist with the 30-meter telescope, and she's going to shortly share some Native Hawaiian cultural perspectives of the moon and moon phases and perhaps eclipses as well. So she should be taking over the audio here momentarily.
Aloha, Roy and friends. Aloha kako to everyone tuning into the live stream. Mahalo for having me. Yes, my name is Leilani Lotzi. I'm joining you all from Hilo, Hawaii. And I guess I just wanted to share a little bit about what the moon means to us here in Hawaii from a cultural perspective. For any of you who aren't familiar with our different moon-related practices. So I guess I'll just start with, first of all, we have our very own Hawaiian lunar calendar called the Kaulana Mahina, the Hawaiian lunar calendar. And essentially it has a name for every single different shape of the moon that is expressed in its 29.5 day cycle. We have 30 different names, and every malama or month, we are able to take very close observations of the moon with the naked eye and be able to tell when particular phases are skipped or when there's two phases in one night, just as tonight the moon actually rose as Pohua and it will set as Po'akua. Actually, that's a little off. Today rises as Po'akua and then will rise as Pohoku. And what that sort of means, there's a lot of different meanings in the Kaulana Mahina, and the most popular ways that it's used is to inform fishing and planting practices. But we're seeing a huge resurgence. Bless you. We're seeing a really big resurgence in the use of Kaulana Mahina in daily lives, and really using it as a way to determine when we should take some rest and care for ourselves, in addition to when we should work especially hard to reach our goals in life, whatever they may be. So Po'akua and other really full moon phases are a good time for that productivity part in the malama. And it's also, to some, Po'akua is a night that you should stay indoors because it's one of those nights in which the night marchers might be out on their trails around the island. I won't explain what that is. You can go look it up, but it's a common sort of ghost story that we have here in Hawaii. Do you have any questions for me, Roy, about the moon calendar? I think my plan is to just hang out here with you all and occasionally talk about some different mana'o, but otherwise hang out and watch the eclipse with you all.
Thank you. So if anyone has questions for Leilani, you can put them in the YouTube chat and I'll share them to her, or maybe she can see them. And I'm also answering questions in the chat as we speak. I put up one version of the Hawaiian lunar calendar that I found.
Yeah, I'll mention one other thing, and maybe as the night goes on and new viewers come on, we can talk a little bit about what is Kalana Mahina again later, and maybe share even a little bit about the Mo'olelo connected to Mahina, to the moon. But one interesting thing about the eclipse in Hawaiian is called Po'uli. And to some, there's not too much information about what the eclipse might have meant to Hawaiians, if there were any specific practices associated with observing an eclipse. But to others, and especially for this particular eclipse, there are some Mahina astronomers, I would call them even people who are cultural practitioners and who are very engaged in observing the moon today, who say that this particular Po'uli, this eclipse, is a really good time for starting anew. It's like a fresh cycle, if you will. So that's something really beautiful. Maybe set some intentions while we observe the moon together tonight.
And someone asked in the chat about solar and lunar eclipses. So solar eclipse is when the moon is between the earth and the sun, and so it blocks out the sun. But solar eclipses are very short because the moon is just about the same size on the sky, the same angular size as the sun. So it only covers up the whole sun for a very short period of time. We're only in the moon's, Earth is only in moon's shadow for a few minutes, between 2 and maybe about 8 minutes at a time, each solar eclipse. Whereas Earth's shadow is much bigger than the moon. So it takes the moon a long time to pass through Earth's shadow. I'll go ahead and pull up the moon here in a few seconds. Yep, as someone's mentioning in the chat, nice clear view from their home. So all you need to enjoy the eclipse, although you won't see all the details of the moon without binoculars, is your own eyes. And probably the color will look more reddish to your eyes than it does through our telescopes. I had a question about how long we'll get to see totality this time. And here in Honolulu, totality starts at 12:16 a.m., so about 55 minutes from now. And it lasts all the way till 1:41 a.m. So it's a rather long eclipse. So we'll get totality in about 55 minutes. Okay, we had a question about why the moon takes on an orange hue when it rises just above the horizon, which is the same reason that sunsets and sunrises are red. And it's also the same reason that when we have when we reach totality, you will see that the moon, instead of being completely dark, even though it's in Earth's shadow, the moon will still be visible and it'll have a sort of coppery, brownish, reddish color. And that is because the Earth's atmosphere scatters blue light. So that's why the whole sky looks blue in the daytime, but scatters red light much less. And it actually bends red light. So that's why at sunset, when the sun is below the horizon, you still get a red horizon because the red light from the sun is being bent to our eyes, refracted by the Earth's atmosphere. So I have a graphic that tries to demonstrate this. So let me switch to that, and it'll take a few seconds to come up. Which is actually good because I can see on my screen here that clouds are starting to go over the moon. So it's going to disappear for me in a few seconds anyway. So we can see in this graphic, the Earth and Earth's shadow, and the fact that the Earth's atmosphere scatters blue light, so it sends it in all different directions, but other colors of light are refracted or bent, and they're bent by different amounts. And the red light from the sun is bent enough that it still lands on the moon. And that's why it'll have that reddish color even during totality. And someone asked why the moon is fully visible during the day when the moon is on the opposite side of the Earth from the sun. So the sun is on one side of the Earth and the moon is on the other. Then you see the lit side of the moon completely. So we see the moon phases, such as a full moon, due to the orientation of the Earth relative to the Earth, moon, and sun relative to each other. So here's a diagram that shows the moon phases. In this picture, the sun is on the right. And you have the Earth. So you see the right side of the Earth is illuminated. So if you are exactly facing the sun, it would be noon. And if you're on the far side of the Earth from the sun, it would be midnight. And then you can see the moon in different places in its orbit around the Earth. You can see that you always have half of the moon lit. One half of the moon is always lit, and one half of the moon is always dark. But you don't see all of the lit side. So if we're looking at the left side of this diagram, that's the situation we actually have tonight. Tonight would be a full moon if the moon in its orbit was a little bit higher or lower than the line between the Earth and the sun. But it just so happens to be crossing that line, so it's actually in Earth's shadow. And similarly, you have a new moon when the moon is between the Earth and the sun, because the side of the moon that's lit, you can't see from your perspective on Earth. And you can see how the other phases work out for that as well. So a lunar eclipse can only happen during a full moon, because the moon has to be in Earth's shadow. It has to be on the opposite side of the Earth from the sun. And a solar eclipse can only happen during a new moon, because the moon has to be right in front of the sun as seen from the Earth. And in the daytime, which is the right side of this picture, all of the right side of the Earth is in daytime. Some of it is morning, some of it is sunset, some is midday. But you can see that there are many phases of the moon that you can see in daytime. So the moon is not only up at night. And we're going to go back to sharing the telescopic view here. And I'll recenter it. And we can see we're getting maybe getting close to halfway to totality now.
Hey Roy, I know I missed your introduction for this, but I was wondering if you had talked about the EV scope a little, because myself and my husband were watching a few of the other Hawaii-based live streams tonight, and we noticed that your view is much redder than the other views of the moon right now. And I think that has everything to do with the capabilities of the EV scope.
Yeah, great question, Leilani. Thanks. So the EV Scope is a brand of telescope. The company that makes it is called Unistellar, and the telescope is called an EV Scope. It's a purely digital telescope. It doesn't have like a regular eyepiece to look through it with your eye, or actually has one, but it's a fake eyepiece. It has a little digital screen inside the eyepiece to give you a fake visual view. But it's got an electronic detector, just like the ones in your iPhones or Android phones. And it's a color detector, which most of the detectors on telescopes that people will be streaming are not. They're usually just sensitive to overall light, and you need to use filters to make color. So the detector on here is trying to figure out what color to basically display, and it's chosen reddish, but it's not actually reddish. The moon would look quite gray if you just went out and looked at it with your eye right now. So that reddish color is just an artifact of the detector. And I was just asking one of the other people who's here in the stream to see if they are ready to share their view, if they're not clouded over, because theirs definitely perhaps presents a much grayer view of the moon than what we see through the EV scope. So when he's ready, when Nick is ready, he'll take over sharing and show his view. So now we're sharing Nick Williford's view. I'm located in St. Louis Heights, and he's over, I think, more Eva. So basically, we're both in Honolulu. He's just using a different telescope with a different setup, and he can either join in and tell us what kind of setup he has, or he'll message me and then I can share it. So Nick tells me that he's using a William Optics Z103 710 millimeter. I'm not that familiar with that scope, but 710 millimeters, so it's about a 7 centimeter, so small telescope or a large zoom lens with a digital camera attached to it. And the camera is a ZWO digital camera, ASI 174 mm. So these are not large cameras and not large telescopes, because you don't need that for viewing something bright like the moon. And it's all on a Celestron tracking mount, so something that lets him follow the moon and not have to move it manually. And for those that are curious about what's up in the sky at night or how the moon phases work and things like that, a great place to go is your local planetarium here in Honolulu. That would be at the Bishop Museum. If you're on Hawaii Island, that would be Imiloa. We also have the Windward Community College has a planetarium that's sometimes open to the public near Kailua. And so it's a great place to go and get a better understanding of the motion of the stars during the night sky and how the moon phases work. If you're looking at the shadow on the image that we have here from a Nick's telescope, you'll see that its orientation is somewhat different from what we had with my EV scope. And that just depends on how the camera is mounted to the telescope. You can imagine that you have the image coming from the telescope, and depending which way you just rotate the camera that's attached to it, you'll see the moon at a different position. And if you're wondering what the features are that we're seeing on the moon, the dark area are called mare, which means seas. Not that they are seas or oceans with water in them, but that's what they look like. And then you'll also see many of the craters, the rays, which are the material that's been blown out of the craters by the impacts. And I'll share a map here of the moon before we get to totality, so you can recognize some of the features that we see on the moon. Probably the most recognizable one compared to the images that we're seeing now as we're approaching totality is Mare Crisium, which is this circular feature that's off by itself. You may recognize the Sea of Tranquility, Sea of Serenity, places where we have landed Apollo missions in the past. You can see some of the large craters, like the largest ones, including Copernicus and Tycho, named after famous early astronomers, and especially the Tycho crater almost looks like a place where the balloon was tied off. And you can see that after an impact, material is ejected from the surface, from the crater, and goes spewing out in different directions and leaves these linear features that we call rays. And because the moon doesn't have an atmosphere, it's impacted all the time. The rocks don't burn up in its atmosphere. And because it's much less geologically active than the Earth, the craters and other things do not get eroded by the actions of water and wind and other natural activity. The Earth still gets bombarded quite a lot by rocks and from space. Many of them land in the ocean, many burn up in the atmosphere, but there are ones that make craters or significant impacts. There was the one in Siberia, the Chelyabinsk event, where something about the size of a Volkswagen Beetle ended up landing on the ground, but as it went through the Earth's atmosphere, it created such a big blast wave that it blew out all the windows in the city and did quite a bit of damage. And actually, the University of Hawaii is the world leader in looking for asteroids that could impact the Earth. And if you're able to go outside and check out the moon, you'll see that we're getting much closer to totality. I'll share what I'm seeing right now. Switch over to my telescope view. We have a question about the lunar eclipse happening every year or at different times. No, it doesn't happen every year because the tilt of the moon's orbit and its crossing of the Earth's orbit, when the so-called line of nodes crosses the ecliptic, it has a pattern, but it's a quite complex pattern and not perfect. So you can find tables, or a very good website for looking up future eclipses is timeanddate.com. They have, and so is earthsky.com. They're great places for checking out the upcoming eclipses. So we won't have another total eclipse for a few more years. for about 3 years. But they come in sort of little clusters of eclipses. So we've had quite a few lunar eclipses in the past few years, and now we're going to get a break. But we will get some solar eclipses in the next few years in the mainland US. And those are certainly much more spectacular than lunar eclipses. And if you have the opportunity to go, or if you're someplace else on Earth where you'll have a total solar eclipse, I very highly recommend taking a trip and checking it out. My family and I went to the one a few years ago that happened in the mainland. We went up near Portland, and it was my first ever solar eclipse, total solar eclipse, and it was pretty remarkable. Lunar eclipses are fun too, and they're much more common than solar eclipses, and they last much longer, but it's definitely worth checking out a solar eclipse, especially if it's someplace easy to get to. The last solar eclipse was only visible from Antarctica, and we had scientists go and on ships in the Antarctic trying to observe the solar eclipse and learn about the outer layers of the sun during that time. So as the moon is going further into eclipse, it's getting dark here on my screen. So I'm going to just change the exposure time to brighten up what we're seeing. So there'll be two upcoming solar eclipses that are visible from the United States. One in October of 2023. That will be an annular eclipse. So the moon's orbit around the sun moon's orbit around the Earth is not a perfect circle. Sometimes the moon's a little bit closer to Earth, sometimes it's a little bit farther away. When it's a little bit farther away, it looks a little bit smaller. And if it passes in front of the sun at that time, it doesn't block out 100% of the sun. Instead, you get a ring of sunlight around the moon, and that's called an annular eclipse, which is quite beautiful. But the sky doesn't get super dark, doesn't get as dark as during a total eclipse. So in 2024, we will get a full solar eclipse that crosses sort of, as someone was saying, from Mexico all the way up to the northeastern US and into Canada. And that will have a totality of up to about 4.5 minutes. So that's a great one to go see. And that will be a total eclipse. So at that point, the moon will be a little closer to Earth. And so it will look large enough to completely block out the sun. And when that happens and you reach totality, you can actually see these amazing streamers of material flowing off of the sun. And the sky gets quite dark. You can see some stars and planets, animals act weird. It's quite a remarkable thing to see. So I highly recommend people go see it. And it's very popular. Probably places like hotels along the path of totality are already filling up. So I'll show here real quick the path of totality of that solar eclipse. So you'll see it starts crosses into Mexico and goes over much of the mainland US. It passes not too far from Chicago, goes into Detroit, Toronto, almost at St. Louis. So Dallas, there's going to be quite a few places to go see it. I would recommend going someplace farther removed from a city, just because there'll be less crowds, and just go out and enjoy it. Make sure you have safe solar viewing glasses so that right before totality and after totality, you can view the sun and see it as it enters eclipse. And it's only right when the sun gets to 100% eclipsed that you can safely remove those solar glasses and see the outer layers of the sun and the materials flowing off of the sun. Make sure you have safe solar viewing glasses so that right before totality and after totality, you can view the sun and see it as it enters eclipse. And it's only right when the sun gets to 100% eclipse that you can safely remove those solar glasses and see the outer layers of the sun and the materials flowing off of the sun. And make sure you have safe solar viewing glasses. And while the dark part of the moon looks totally dark in the image from our telescope here, if you go outside, you'll see that it's still actually illuminated, and you can see that part kind of looking reddish now from the refraction of the red light from the sun through Earth's atmosphere. You all might have heard of a supermoon. That's when the moon is closer, a little bit closer to Earth in its orbit. It changes by about 10%. So a supermoon, the Earth looks about 10%. During a supermoon, the moon looks about 10% bigger than average, and during a mini moon, it looks about 10% smaller. So I think the last lunar eclipse was close to a supermoon, so it looked a little bit larger, if I recall correctly. So I had to step away from my computer and take a look at what the eclipse looks like with my naked eye. And I can see that the lit edge is very bright. It looks completely overexposed, even to my eye, while for me to be also able to see the eclipse part. And that's actually a lot easier with our eyes, because our eyes kind of auto adjust to having something bright and dim at the same time, whereas these detectors, the digital cameras, just look at total brightness. So I'm going to take a shot first at recentering the moon here, and then let's see if we can get the dark part to show up. So there'll be some experimenting going on with the images. That's a great question about the bright edge of the moon. I don't know that there's a name of the beam of light when it's almost eclipsed. During a solar eclipse, you can get a diamond ring effect where right before the eclipse, you get a very bright spot. But our eyes are what are called logarithmic detectors, so our ears. So things that are 100 times brighter don't look 100 times brighter to us. They only look somewhat brighter. And so we can see things that are faint and bright at the same time. But as you'll be able to see, as I crank up the exposure time, there we go. Now I can see some of the eclipse part of the moon. Oh yeah, there we go. That looks good. The rest of it gets completely overexposed. But that looks pretty good. There we go. For those that are trying to take photos, you're stuck with the same thing my digital telescope is stuck with, and all of our digital cameras, iPhones, and things like that are stuck with. You know that if you try to take a picture of something faint and something bright in the same frame, you cannot get them, even though they look good to your eyes. So that's just because our eyes and our brains can process that and correct for the fact that there's something bright and faint, but the cameras cannot. That's the same way that our ears can hear faint things and loud things at the same time. That's the decibel system, if you've ever heard of that for sound. Decibel, something that is 10 decibels is not 10 times louder than something that's 1 decibel. It's many, many, many times louder. Same with earthquake magnitudes. Now the moon is starting to look quite a nice coppery red color on the dark part. And we're only about 10 minutes away from totality. For those who missed it earlier, the reason the moon is going to look red is that the Earth's atmosphere scatters the blue light, sends it in all different directions, but it refracts, bends the red light. And so even though the moon is in Earth's shadow, the sunlight that would normally just go pass right by the moon, the red light from the sun is actually bent onto the moon. That's why at sunset, even though the sun is below the horizon, you get that red area near the horizon, and then it switches from yellow to green, exactly from this refraction effect that you can see in this diagram. Someone asked, why does it seem so slow to be reaching totality? Actually, the moon is moving at the same rate, so it's entering the shadow at the same rate. It's just that our eyes are auto-adjusting. So I think what seems bright to you now, and we're getting pretty close to totality. I can, even as I'm watching here on the screen, I'm going to switch back to the view of the eclipse because it's starting to look pretty darn good. Our eyes are trying to see the bright part, just like in a dark room, our eyes try to open up and see what they can. So we're sort of, what we are perceiving as bright now is not as bright, it's not truly as bright as what we perceived as bright earlier. In fact, as you can see on the screen, the dark part of the moon is quite dark. And if I crank up the exposure time, then we'll be able to see more of the dark part of the moon, but the bright part will appear brighter. And our eyes are sort of doing that all the time. That's one of the reasons we have tools to measure things, because our human brains and sensory systems are not perfect and are not good at making quantitative measurements. And Leilani, if you're here, I'm wondering if there's anything that you can tell us about Native Hawaiian terms for eclipses, or if they had specific meaning in Hawaii.
Sure, yeah. Aloha, everyone. It's Leilani again. Yeah, I'm here just listening, Roy, to all of the info you're giving, which is awesome, and I'm really enjoying the different live streams your other co-hosts here have to offer. In addition to watching 3 other live streams that are all taking place from Hawaii tonight. And it's funny that you ask about the translation, because I was just doing a bit more reading on it. And for those who don't know, eclipse in Hawaiian is po'uli. The lunar eclipse in particular is po'uli. And if we think about what the 2 different words within this single word mean, po meaning darkness, night, even to some the unfathomable darkness from which everything comes from. It's the source of creation within the Kumulipo. And it's really
Getting
just
quite
beautiful.
close to totality now.
Oh,
for those watching the stream and also looking outside, the stream is delayed by about a minute. So you might see totality happen in real life just before you see it happen on your computer screen here. And I've adjusted the exposure time so that we can now see the completely eclipse part of the moon, as well as the bright edge. And you can really see that nice red color coming out now. and some clouds. We have one little tiny cloud passing overhead right now, so hopefully that'll go quick and we can continue enjoying the eclipse. We're going to have Nick share his stream, hopefully, because I am currently clouded out.
While Nick gets that screen started, or it looks like you might have yours back up, Roy, I'm going to finish a little bit of the translation explanation I was doing earlier. We had a little technical difficulties here, and so I paused for a moment. But I did explain the meaning of po within po'uli, the Hawaiian word for the lunar eclipse. And so then looking at the word uli, I think most people are familiar with the translation of uli uli being the one of the words for blue. But if we look up uli without the okina, even on Vehe Vehe Wiki Wiki, which is my favorite translator, it's what UH Hilo students use. Just uli without the okina in the front is any dark color, including the deep blue of the sea, the ordinary green of vegetation, and the dark of black clouds. So when you think about it for the eclipse, and the eclipse being po'uli, we're looking at like the darkest part of the night.
And it looks like we are just reaching totality. It's the teeniest, tiniest sliver of a lit edge, but that will be gone shortly. Oh, we just hit some clouds, but we'll have totality for an hour and 15 minutes or so. So hopefully we'll get the view back soon. Clouds are the bane of astronomers. Even if you're on a telescope observing, you've been assigned a specific night usually. Then if it's cloudy, you lose your night and you have to request the telescope time again. All right, I've got a little bit of clouds coming and going, so I'm going to take this moment to put up this graphic again of what we're experiencing right now. So what we have is the moon passing through Earth's shadow, and we were waiting for totality. Now the moon has entirely entered Earth's shadow, and it's going to be transiting through Earth's shadow for the next hour or so. And then we'll start to see the moon come back out of eclipse as it exits the shadow. And then it'll be this dark part of the shadow is called the umbra. You may recognize umbra like umbrella. And then it'll go into the penumbra, which is where the Earth is only blocking part of the light from the sun. And then during the penumbral eclipse, the moon will not really appear much different than it does regularly. It'll be just a little bit darker. So since totality lasts till about 1:30 or 1:40, we'll be on till then, and for a little bit of the exit, and around 2 a.m. we'll sign off so that we can get some sleep. Now we've got some clouds passing again. Hopefully they'll go quickly.
Aloha kako again, everyone. This is Leilani tuning in from Hilo, Hawaii, and we feel very lucky right now here in Hilo to have a clear enough sky to view Po'uli with everyone tonight. Po'uli, of course, being the Hawaiian word for the lunar eclipse. And I just wanted to invite everyone who is watching from Hawaii, anywhere in Hawaii tonight, to look at some of the different stars surrounding the moon tonight as we are entering that fuller part of our eclipse. Here, a lot of the stars are much more bright, more apparent with the darker moon. And is one little particular cluster of stars is especially important to us here in Hawaii. And that is, of course, the Makali'i or the Pleiades, the closest star cluster to our planet. And it's really cool to see Makali'i so close to the moon on rare occurrences like this, because as we've mentioned in this stream, when the moon is really bright, it washes out the light of surrounding stars. And so to have Makali'i so close to the moon is just really a really cool sight to see. And for some, Makali'i is the shape of a rat called Iole, who is featured in a few different hula during the Makahiki season. And so Makahiki is a time of festivities and all sorts of celebrations and peace here in Hawaii. So Makali'i and the season of Makahiki is coming very soon. And right now we are in the Hawaiian lunar month of Vilehu. And so following Vilehu, we will enter into what some call Makali'i and some call Makahiki. That's just a little fun tidbit to share with you all tonight.
Well, again, if anyone has any questions about astronomy or the moon or telescopes, doesn't have to be about eclipses or what's going on right now, we're happy to answer them. If I know one of the teachers that we've gone and done work with before is right here on the stream, on the chat with us on YouTube. But if you're a teacher or you have kids in school and you're interested in having us come out and do some outreach activities with you in person, we'd be happy to do it, at least here in Hawaii, where we can go to you. We have staff on Maui, on Hawaii Islands, and and Honolulu. And we can also go to other islands. We've gone to Lanai and to Molokai and Kauai, and we're happy to come out and do activities with students or groups like Girl Scouts, Boy Scouts, and other educational organizations. Looks like I'm getting hit by some clouds here again. So let's see if we can get an alternate stream. And in the meanwhile, let's bring up the map of the moon again. So you go for all the named things on the side of the moon that's facing the Earth. So we always see the same side of the moon. We don't see the dark side of the moon. And that's because the moon is what's called tidally locked to the Earth. That means the same side of the moon is facing the Earth at all times. Even though the moon is going around the Earth, we see the same side. That actually means that the rotation period of the moon is the same as its orbital period. Because if you imagine you're standing in the middle of a circle and someone's walking around you in that circle, in order for you to always see their face, they would have to slowly be turning so that their face is always pointed towards you. But they'd have to turn once for every time they go around you. So that's due to the tides, actually. And that happens not just with the moon and the Earth, but it can happen with planets and stars. And so we always see the same side of the moon. We need to send spacecraft to probe what's on the other side that we never see. And that has been done. And that also means that the dark side of the moon is a great place, for instance, if you could imagine building a telescope there, because it's always dark and cold, which is good for many kinds of observations. And there's no atmosphere. The atmosphere absorbs certain colors of light that we might want to observe, like ultraviolet and infrared light. If you have a pair of binoculars, that's a great way to go out and enjoy the moon with or without an eclipse. You can see lots of details. And if you go out when the moon is at a crescent phase or a gibbous phase, when it's partially lit, you can see the shadows of the elevated features of the moon along the terminator, the place where it goes from dark to light. And you really get a good 3D effect. Well, someone's asking about north and south, and those are just terms. So north is not better than south, and south is not better than north. The fact that we have maps typically shown with the direction we call north up is a bias of the fact that a lot of the map making that whose legacy lives on today happened in the northern hemisphere, whether it was in Europe or in Asia or later on in North America. So, but cultures in the southern hemisphere had their version of up, south up in their maps, and so that is just a cultural bias of how we draw things in maps. Typically, there's no up or down in space, so we could rotate things whichever way we wanted on the Earth. Earth does have magnetic poles which don't align with our rotation axis and which do shift. And even our rotation axis doesn't point in the same direction all the time. Earth actually wobbles like a top. So if we look at right now, the Earth's north axis, its north rotation axis, points towards Polaris. But in 15,000 years, it'll point towards Vega, which is quite far away. It's quite a large wobble. So even what we consider north on the sky changes, and then the direction north of our magnetic pole is different than the direction north of our rotation axis. Okay, since I'm going into clouds, Alex Djerba, one of our uh, other astronomers joining in, he has Uranus up on his telescope. So we'll take a little bit of a break from totality of the eclipse to go check, hopefully to go check out Uranus. So in this wider field view from Alex, you can see the clouds passing over the moon, but you can also see Uranus up and to the right from the moon. And you can tell that it's very much whiter or bluer looking than the eclipsed moon. And Uranus is actually blue looking because of the hazy clouds and the chemicals that make up Uranus's atmosphere. And you can see Alex is using a completely different system than both Nick and I were using. There are lots of options for astrophotography. You can essentially buy one of a large variety of telescopes and one of a large variety of digital cameras and assemble them together to set up your own system. And he's got a much wider field of view. The angular size, the size of the moon on the sky, is about half a degree. So you can see he's got something like a 2-degree field of view, whereas the EV scope I was using, it has a fixed field of view of about half a degree. And with a change of camera, Alex could have a much narrower field of view and see much more detail. But he's chosen to go to this wide field view since we knew that the moon and Uranus would be close to each other on the sky. So Alex is observing with a 107 millimeter refracting telescope. So it uses lenses instead of mirrors. Our modern large telescopes that we use for most astronomy research use mirrors, but he's using a smaller refractor with a Canon DSLR attached to it. So a nice commercial telescope with a nice commercial DSLR. And right now, both Alex and I are staring at dark sky due to dark images due to clouds. He's got a little bit more light than I do, so I'm going to keep him on the share as long as I can. Nope, he's completely blacked out. So let's go ahead and look again at eclipse geometry. So this diagram shows the Earth as it orbits around the sun. And I remind everyone, nothing in this diagram is to scale. The Earth is not nearly the same size as the sun. The sun is 100 times bigger across than Earth. The moon is about a quarter of Earth's diameter. And the orange circle here shows the Earth's orbit around the sun. And the smaller circles around the Earth show the moon's orbit around the Earth. And what you can see is that the moon's orbit around the Earth is tilted. It goes above and below the Earth's orbit. So most of the times when, for instance, we have a full moon, what we have is the sun, the Earth, and the moon in a line, but not in a perfect line. The moon is actually above the Earth. It's above the line connecting the Earth and the sun. So it's not an Earth's shadow. So we see a full moon. But if it so happens that that tilted orbit of the moon crosses the plane of Earth's orbit around the sun, as it does in the situation in the lower left of this diagram, then you get a lunar eclipse. That's what we're seeing now. The sun shines towards the Earth and the moon, but the Earth's shadow makes the moon dark. So that's the situation we're seeing now. And it's cleared up where I am. So let's go back and look at this beautiful coppery red moon.
Aloha Kako from Hilo. I just wanted to tune in, check in with all of our newcomers and welcome you, especially those of you who might have clear skies tonight in viewing Po'uli with us, or the lunar eclipse from Hawaii. We are approaching totality of this eclipse very soon. Here in Hilo, we're very lucky to have a clear sky. It's really quite beautiful. And we even have had a couple of shooting stars, and these little streaks across the sky actually reminded me that right now is fledgling season for one of our native seabirds, the ua'u. And so if you're enjoying how dark and clear your skies are from wherever you are, you might want to consider keeping our skies very dark through whatever choices you make in outdoor lighting and maybe letters to the county about light pollution, things like that. Oahu are very easily affected by um, artificial lights, and they sometimes fall out of the sky on their migrations or paths back to their nests as they're distracted by these lights. We also, with our nice dark skies, can see a whole lot of stars tonight. And if we look towards the north and we look at Cassiopeia, this sort of 3 or W shape constellation in our northern sky, in Hawaii, we call this constellation Iwakeli'i, which is another native seabird here in Hawaii. And what's really cool is that Iwakeli'i is circling the North Star throughout the year, and therefore is only visible for a certain portion of the year, the portion of the year in which it's fledgling season for ua'u. So you could think of it as Iwakeli'i circling its nest. It's visible out to sea to us now during this time of year, and in a few months it'll be back below the horizon.
Thank you, Leilani. And for those who are out shopping for light fixtures, some hardware stores, I know Lowe's carries outdoor light fixtures that are certified by the International Dark Sky Association. They'll have a logo or something on it that says Dark Sky Certified. And those will usually have some kind of shading that keeps the light going down instead of in all directions. The worst thing that you can buy is like those globe lights that basically send a bunch of light up into the sky. And with our stratospheric electricity prices, you don't want to waste electricity and send light into the sky that you just want to send down into the ground. So if you can use a light bulb that uses half the power and just send the light down, that's a great thing to do. So anything with shielding or that directs the light down instead of up is great. And you also don't need very high brightness. A lot of people think that a very bright security lights will deter thieves, but in fact, all it does is light up your backyard so they can find things, or your garage, or whatever it is. And studies have shown that brightly lit yards aren't, and houses aren't, do not deter thieves. So we recommend that you try to keep your area as dark as possible, maybe use motion sensors or anything else to reduce the amount of light that you're emitting into the sky. The sky is a heritage for all of us. All of us share the stars and the planets and enjoy the night views. And if you ever get a chance, if I'm living here in Honolulu, I grew up in New York, but if you go to a very dark place, whether it's Kaina Point or you get to go someplace on Hawaiian Island away from the cities, it's really remarkable to see what's visible and what you can imagine that ancient cultures saw before the advent of electricity and all of the lighting that we have now. And luckily it's also cleared up, so we've got a view of our beautiful blood red moon back on screen. Someone asked if the color of your lighting makes a difference for dark skies, and the answer is absolutely yes. So blue light scatters more than red light. That's why, at least in our atmosphere, that's why our whole sky is blue. So if you get light bulbs that have a lower, what's called color temperature, often light bulbs are rated by color temperature. And a high color temperature means the light bulb gives off a lot of blue light. Those LED lights that are super bright white, some car headlights are like that. A lot of the ones you've been seeing in parking lots, what they installed along the H1 freeway here in Honolulu are those very bright white, bluish white lights. Those are awful because that blue light from those scatters up into the atmosphere and makes our sky bright. The yellow light doesn't scatter as much, and therefore it makes the night sky less bright. So definitely you want to get a warmer color temperature, so redder or yellower seeming bulb instead of the ones that are bright and bluish. So someone commented about light pollution. We actually have, some of the counties here have quite stringent light pollution ordinances, although they're not enforced that well, I don't think. Maui and Hawaii Island in particular, because of the observatories. And we did work with, someone commented about light pollution. We did work with the county, for instance, in Hawaii Island, when they replaced the sodium vapor lamps that they used to have with those very yellowish looking ones with LEDs to develop filtered LEDs that don't get confused for yellow traffic lights, but also don't give off a lot of blue light. So if you're ever in like on Hawaii Island and you see those newer streetlights that they've installed over the last 5 or 10 years or so, they're kind of yellowish looking. Those were designed with the help of astronomers to try to mitigate the light pollution from them. And even though they make things look a little bit funny colored, they're actually really good at keeping light aimed downwards and producing sort of a gentle glow that reduces glare. The other big problem with very bright light bulbs is that they produce a lot of glare and they make it hard for you to see someone hiding in the shadows, for instance. So you definitely want something that produces a more diffuse, even lighting. And historically, the blue LEDs have been cheaper to produce. So that's changed over time. But that's why a lot of places, when they switched their street lighting to LEDs, just went for the cheaper, bluer ones because it was a big difference in money. In some cities, they call those bright bluish white LEDs zombie lights because they make everyone look like zombies. I think in Davis, California, the city wanted to save money on electricity and installed that kind of lighting. And there was such an uproar that they had to go and replace it with a more pleasant color of LED bulb later. The other thing that can really help is shielding. So if you install shielding around the street lights that keeps the light from going up into the sky and instead directs it back down, then that definitely keeps the sky a lot darker. And unfortunately, if you look at the LEDs all around Honolulu, at least they are not shielded. The street lights are not shielded. there are places in the world that are called dark sky preserves that have gone through specific procedures to be internationally recognized, and some of them are culturally important sites. Some of them are important for stargazing, and so you can look those up online and pay a visit to one if you'd like to see what an ancient dark sky would have looked like. I know personally my first ever experience at a telescope was when I was actually in college, and I went observing in Chile at Cerro Tololo Observatory. And I grew up in New York, as I said, and the sky is very bright there. But when you go to the southern hemisphere and when you go to up to the mountains there, it's extremely dark, but the Milky Way is also much more visible. You're from that hemisphere looking more towards the center of the Milky Way. And it's absolutely remarkable to see a super bright Milky Way just spanning the whole sky. You can really imagine people's just being completely in awe of what was out there. And I think we've lost that in the cities today. Someone asked, is there a peak in how red it's going to get? And we've actually, the maximum eclipse happened about 5 minutes ago. So that's when we were in the deepest part of Earth's shadow. So that's probably as dark and as reddish as it's going to get, but we'll still be in totality for another 40 minutes or so. As someone commented in the chat, we do lose our night vision really quick, which is why we're taught to drive with averted gaze, to not look at those oncoming headlights. But if you ever do have a situation where your night vision is messed up, or you go from a really bright sunlit area into a dark room and you want to adapt your eyes quicker, looking down and blinking a lot does help that adaptation occur more quickly.
Now that we've passed the peak totality, I think I'm feeling a little sleepy here in Hilo. So I just want to wish everyone a hui ho and mahalo nui for having me on your live stream tonight, Roy. It was a really great night to watch Po'uli with you all. And I hope that everyone here continues to kilo or observe the moon in all future nights as well, and see how it changes throughout every day and every night. Mahalo.
Mahalo, Leilani, for joining us and sharing your mana'o with everyone on the stream. I learned a bunch too. Have a good night. No, as you can see on the stream, we've got some clouds, but since we've got a little bit of time left in totality, and I can see that Orion is in a clear patch, let's take a few minutes and swing the telescope over to the nebula in Orion and see what that looks like. This electronic telescope is kind of neat because what it will do is if it goes and observes something fainter like the nebula in Orion, it'll keep adding up images and we'll slowly see a nice view of the object that we're looking at build up. And then we can come back and enjoy the moon. So let's do this little experiment just for a little change of pace. I hope that's okay with everyone. Bye-bye moon. So you just saw it go, the moon go disappearing away. And you can see the telescope says it's slewing. This telescope is pretty slick. You just set it up and level a tripod. And then you point at an area where there might be a couple of stars and you say align. And by looking at the pattern of stars that it sees in its field of view and matching that to a catalog, it will figure out where it is, and then it will know how to point everywhere else. So it does not require a great deal of knowledge to operate. So when we get to Orion, and assuming the clouds are not blocking Orion, it'll take a little bit of time for the image to add up to start seeing the nebula. Okay, so the telescope has arrived on target, and right now it's just taking a bunch of short exposures, but I'm going to set it to start trying to add up those exposures and get us an image of the nebula. Hopefully it'll take only about a minute. And I'm going to go make sure there's no clouds around. All right, well, that was pretty spectacular. So what we're looking at here is one of the stars in Orion's belt. And that star, and you can even see this with a pair of binoculars, is actually a stellar nursery. It's a nebula. A nebula just means something fuzzy in the sky. A long time ago, when astronomers didn't know that galaxies were actually distant galaxies, they called them nebulae as well. And there are planetary nebulae, which have nothing to do with planets, except that they look round, but they're the remnants of dying stars. There are supernova remnants. But Orion's nebula is actually a stellar nursery. And the dark areas that you see are filled with gas and dust, so much dust that the light from the stars can't get through it. But you also see the bright stars here in the center. Those very whitish, bluish stars are much hotter than the sun. The sun is about 6,000 degrees, 5,800 degrees Kelvin, or about 11,000 degrees Fahrenheit. But these stars can be 20,000 to 50,000 degrees Kelvin, so approaching 100,000 degrees Fahrenheit. And they live very short lives. But they're so bright that they kind of blow away the material of the stellar nursery and then expose the smaller stars that are left there within. So if you look at the Orion Nebula, even with a pair of binoculars, you can see the fuzziness. But this is what it would look like through a small telescope if you could expose for a little bit longer period of time than just looking with your eye. So that's a fun little break from looking at the moon. Oh, excellent question. Someone asked about Carina Nebula. And yes, that's a stellar nursery too. And in fact, that's a teeny tiny portion of a much bigger stellar nursery. So James Webb Space Telescope's field of view is tiny compared to this telescope's. It looks at things in great detail. So this telescope's field of view is half a degree across. The James Webb Space Telescope's field of view is about 1/50th of a degree across. So it's looking at much finer detail. So like if you tried to look at Orion, you couldn't see all of this. You'd see one small patch of it. The nice thing about this telescope is also that it takes color pictures. Usually when we use like a DSLR camera with a telescope, we're going to get grayscale pictures. So just kind of different shades of gray and black and white. And then we might take a picture with a red filter and a green filter and then, or blue filter, and then have to add them together later to make a color image. But this does that sort of automatically. All right, Alex says he's got a great view of the moon now from where he is, so we'll switch over to him. So a nice spectacular wide field view of the moon from Alex. And you can see, again, his orientation is different from what we had. And you can see that we're starting to exit. We're still in totality. We have not yet left totality, but you can already see that we're not in the deepest maximum eclipse. We have about 23 minutes till the total eclipse ends. If anyone has any questions, I'm still monitoring the chat here. I see some of our astronomy undergraduates from the University of Hawaii have joined the live stream. Nice to see you all up. Here's a question about the color of the images from Alex's telescope, which looks much more like what our eyes can see versus what the EV scope produces. And I'll see what Alex tells me about that, or if he wants to chime in, can do so. But I think he has the ability to adjust that to some extent with his camera, and I don't have that capability with the EV scope.
It's just a matter of what happens. Roy, it's just a matter of white balance with the camera.
Yes. So as Alex said, cameras do white balance. So you can, he has a DSLR, so a nice digital camera that allows you to basically set what counts as white. And that basically makes it look natural color. And there's also a question about what to see in December. One of the big things in December is the Geminids, which is one of the biggest meteor showers. So that'll be happening in mid-December. And we'll also have Mars at its closest approach to Earth and fully illuminated, so it will look very bright in the sky. I'd say those are two easy celestial events that you can do with binoculars or just going out and looking for the meteor shower naked eye. So we've got about 30 minutes left of totality here, and then, or maybe a little bit less. So one of our undergrads in here, Quentin, has asked about software for stacking images. And actually, I only do that with professional telescope images. And I've used an ancient software package called IRAF or modern tools using Python to add those together, but that's not what you want for like the DSLR images. And I actually don't know what are good ones from an amateur perspective. Maybe Alex knows.
Yeah, for planetary, a good app to use is one called AutoStackert. So it's AutoStackert, AutoStackert. So for capturing planetary images from using video capture, AutoStackert is good for stacking frames from videos. For stacking deep sky objects where I'm taking long exposure images, the sort of the standard best package really is the PixInsight, PixInsight, PixInsight. So that one's good for stacking still images.
Thanks, Alex. And it looks like you might be clouded out, and I have an opening, so I'm going to switch over to sharing mine. Well, for those listeners who are in Hawaii or people who are visiting Hawaii, if you ever want to go up to Mauna Kea and check out the observatories there and just see the summit and that area, it's quite spectacular at sunset and sunrise, especially. It is very cold though. There's already some snow up there at the summit. It's almost 14,000 feet elevation, but it is a very, very special place. It's a very special place here culturally. And it's also a very unique place to do astronomy with excellent atmospheric conditions. And so it's meaningful to a lot of people in a lot of different ways, but it's a powerful place to go and experience. So if you have the chance, I highly recommend going up there. You are required to have a 4-wheel drive vehicle, and you're required to stop at the visitor station at 9,000 feet for about an hour to acclimate so you can get used to the altitude. And I switched back to our view of our nice blood red moon for today, or for this evening, this morning, I should say now. Just briefly, I'm switching here to this website, which I like to use for seeing what eclipses and other things look like. It's really excellent, timeanddate.com. And you can see here, it's actually showing us how this eclipse is progressing. You can see that we are approaching the edge of Earth's umbra. It knows where I am, but you can put in where you are, and it tells you when it's visible. So here it is for Honolulu. It gives us the correct orientation. It gives you the times when the eclipse begins, and you can see we're now 9 minutes from the end of totality, and tells you which direction to look at and how high up, and it even gives you future eclipses that are visible where we are. So it's an excellent website, timeanddate.com. I just went out and took a look with my own eyes at the moon, and you can definitely see that the eclipse's totality is going to be coming to an end. And even if you're enjoying this stream, if it's clear outside where you are and you can see the eclipse, it's worth checking out with binoculars, with your eyes, as well as on the stream to see what all different views look like, give you different perspectives. And I want to really thank Alex for joining in and sharing his stream, and for Nick for joining earlier. With our multiple points of view, we managed to pretty much have coverage where we could see the moon at any time, despite some intermittent clouds. We're pretty lucky because the weather map looked kind of questionable earlier, but the clouds have broken up. It was actually sprinkling here where I am an hour before I started the stream, and I was worried that I'd be in rain and not be able to observe, and it's turned out quite nicely. So thank you to the weather powers for making it nice for us. For those of you in Hawaii or who want to keep anywhere in the world who want to keep informed of astronomical events and news, public activities that we'll be doing, we post our information on Instagram, Twitter, and Facebook. We are UHIFA, as in UH Institute for Astronomy, UHIFA on Twitter and Facebook, and there's an underscore between the UH and the IFA on Instagram. But I think if you just put in UHIFA, you'll find us. And you can also go to our website, which is ifa.hawaii.edu, to see recent news stories and events that are coming up. And I'd like to thank everyone for joining us and viewing and asking questions in the chat, keeping us on our toes. I think it's going to be pretty exciting to have humans back on the moon in a few years. And they may be onward to Mars. Or we have this amazing view of the moon from Earth. Certainly the views that we've gotten from spacecraft around the moon, and the images from the Apollo astronauts are quite spectacular, especially looking back at Earth and reminding us of our little island home in the universe. So I can only imagine with our current video technology and other things, what kind of amazing images we'll have. Thank you all who tuned in, and you're all very welcome for sharing. We love sharing what we are learning and what we know, and all the things that we don't know about the universe. I'm going to take a little break from the moon and swing us over to see if we can get a decent view of Jupiter while we're over here. So let's go fly over there. We should get there soon. And I was looking at it earlier, and we could definitely see some of the Galilean moons, the 4 moons of Jupiter that Galileo observed: Io, Europa, Ganymede, and Callisto. And they orbit Jupiter so quickly that you need to look at a diagram for every day to see which moon is where. Uh-oh. Well, that's unfortunate. It looks like its pointing is a little bit off. So even though I can see Jupiter on the sky, it missed its target by a little bit. So let's share this eclipse geometry graphic while I go try to find Jupiter. Okay, there was a great question in the chat, which is a really common one that we get, which is there an easy to use telescope that we recommend? And finding things with the manual telescopes is hard. So I have two recommendations or three recommendations in that vein. One is to start with binoculars. That's always a great way to start. Two is to get a telescope that has what's called go-to functionality, which basically you get it to point at 2 or 3 bright stars, and then it knows where it is. And as Jasmine beat me to the punch in the chat, she says the Celestron next stars are great. I actually just bought a year ago or so a Celestron Next Star 130 SLT for us to use at events. It's small, it's compact, it is pretty easy to set up and align. And once you've got it aligned, you just type in on its little keypad what you want to go to next, and it goes there. And then usually you can see what you're looking for in the viewfinder, and then you're good to go. So definitely aligning a manual telescope and going from one place to other takes a bunch of practice and skill. And I would say is one of the biggest failure points for people who start out buying a telescope and then they never use it again because they can't get it aligned. Learning how to use the wide field finder scope that comes with the telescope, making sure that the finder scope and the telescope are looking at the same thing, which you can do in the daytime by looking at some light off in the distance. Those kind of things really trip people up. And a lot of the inexpensive telescopes that you can buy at a sort of like a Target or Walmart or whatever kind of store are for the most part junk. So you probably need to invest a few $100s to get a decent telescope. The small Next Star 130-ish telescopes are in this sort of $500 range. And as Jasmine says, it'll figure out where it is after a 3-star alignment. And we have actually in the daytime used our Celestron Next Star with a 1-star alignment, that is to point it at the sun with the solar filter and say, hey, that's the sun. And then it will track the sun for an hour or two pretty well. So that's pretty good. All right. I've gone back to the moon since we're starting to come out of totality now, and we're going back to seeing a nice bright edge there. So there we are. There's our view as we exit totality. The only issue with getting a GPS go-to telescope is you need power. So it eats batteries pretty quickly. We bought a little portable power pack to go with it, which Celestron sells one, but I just went to Battery Bills and got one that'll run it for days on end. But it's like, looks like a little car battery almost. Another option, if you want something simple and easy to transport, is to get a Dobsonian telescope, like a 6-inch Dobsonian, fully manual. The mount system is really simple. You can't track anything with them, but once you learn how to use a finder scope on it, you start out with the eyepiece with a wide field of view and get aligned, and then switch to an eyepiece with a narrower field of view. They are incredibly easy to set up. You can just put the pieces, the base and the tube in the trunk of your car and take it anywhere to go observing with basically no setup. That's actually what kind of telescope we use for introductory astronomy labs for our undergraduates, a Dobsonian telescope. and they're very inexpensive. For about $600, you can get an 8-inch aperture telescope, which is quite big. And we teach our students how to align them in, I don't know, 15 minutes or something like that. It's definitely a good idea to start with a smaller, inexpensive scope. You don't need the large aperture unless you're going to a really dark site and want to do dark skies, astrophotography, or something like that. As someone put in the comments, a little Skywatcher or Dobsonian is a good choice. And having a manual telescope is a mix of hard to use because finding objects is a little bit of a challenge, but once you learn how to master it, it's pretty easy. It doesn't take long. Well, we're coming up on 2 o'clock, at least 2 o'clock here in Hawaii. And the sad reality is that I need to be up at a little after 6 to get my kids to school. So in a little while, we're going to say goodbye to this stream and to the Eclipse for sharing with you all, but you're all welcome to go outside and continue enjoying it. And if you have folks who've slept through it, you can, this stream is recorded and will be sitting there on our YouTube channel in the future. And you can find other videos of some of our past public presentations and celestial events on our YouTube channel. Oh, yes, Quentin is noting that your choice of eyepiece is important. So both the quality, but also the focal length. If you get a small focal length eyepiece, then you will have very high magnification, but you also have a tiny field of view, and finding things will be impossible. So starting with a larger focal length eyepiece, which will give you a wider field of view, will make it easier to find something. And then once you centered it with the wide field of view, then you can put in narrower field of view and enjoy the detail. So a lot of times those cheap department store telescopes will say 500 times magnification, and they achieve that with a very small, short focal length eyepiece. But with that very high magnification and a small telescope, you can't see anything. And it's very hard to center. We have someone in the chat, Yuli Preston. She's a teacher here in Honolulu at one of our schools. And we did some outreach activities at her school, and she's got a crew of 6th graders hanging out with her. Now, they can stay up late because the state schools here are closed for election day tomorrow, so they don't have to go to school and they can sleep in. Otherwise, I'm sure they would be sleeping through class tomorrow. Wow, you can just watch the moon just making its way out of Earth's shadow now. You can just see the sunlight lighting up more and more of the moon in real time on this video. It's pretty impressive. All right, folks, it's almost 2 o'clock. So thank you all for joining in our live stream. We're going to say good night. Thank you for joining us again and for all the great questions. As I noted, you can follow us on social media and on our website to see what other events are going on in the sky and what other public events we'll be doing. And we look forward to seeing you all either in person or virtually in the future. So thank you very much and good night. Ahui ho.